initially, so that's when t is 0, there were 100 individual animals, so the population is 100. So let me substitute this information into the equation. P is 100 when t is 0. Now, the a to the power 0, we know that anything to the power 0 is just 1. So our numerator becomes 125k times 1, and our denominator becomes k plus 2 times 1. We can now multiply both sides by k plus 2, so 100 times k and 100 times 2. Subtract 100k from both sides. Divide by 25, and k is 8, which is what we needed to show. So that is part A done. We are also told that the population doubles after 5 years. So that's when t is 5, the population is now 200. So let's substitute that information into the equation. So the population is 200. Now we know that k is 8 now, and t is 5. The 125 times 8 is 1,000, so we can simplify that a little bit. And same idea as before, really. We're going to multiply across, so we've got 200 times 8 is 1,600. 200 times 2a to the power 5 is 400a to the power 5. We'll subtract 400a to the power 5 from both sides. Divide by 600. And then we're going to take the fifth root. To find that a to 4 significant figures is 1.217. Part C of the question says to determine the value of t when p is 400. So, let me just update this equation, because we now know what a is and we now know what k is. So just updating that equation, the 125 times k is 1,000. The a is 1.217. And that's going to be to the power t. On the bottom, we know that k is 8. And again, we know that a is 1.217. And we need to find the value of t when p is 400. So let's put 400 here. Right, let's solve this equation. So we'll multiply across. The 400 times 8 is 3,200. The 400 times the 2 is 800 lots of the 1.217 to the power t. We'll subtract that 800 lots of the 1.217 to the power t from both sides. We'll divide both sides by 200. And now we can take logarithms. So, taking logarithms of both sides, the 3,200 divided by 200 is just 16, so I'll simplify that. Use the laws of logarithms to bring the t down to the front here. And then divide both sides by the log 1.217. So log 16 divided by log 1.217 gives 14.12. So that's the value of t when the population is 400. Last part of this question, part D, says explain why this population cannot exceed 500. So again, let me just write down the formula. We've got that the population is 1,000, lots of the 1.217 to the power t, so I'm going to divide the top and the bottom by 1.217 to the power t. And the reason why I'm going to do that is because now the t is only going to appear in one place in my equation. The numerator is just going to be 1,000. The denominator, I've got the 8 divided by the 1.217 to the power t. And then I've just got a 2. Now, what I'm going to say is, as t tends towards infinity, as t becomes a huge number, this term here, 8 divided by the 1.217 to the power of a huge number, that's going to become 0. So let me just write a little sentence to finish this question off. As t tends towards infinity, 8 over 1.217 to the power t is going to tend towards 0. Which will mean then that the population will just tend towards 1,000 divided by 2, because that's all that's left of this equation. This is gone. We've got 1,000 divided by 2. So the population is going to tend towards 500 and cannot exceed it.